Okay, so Java introduction. To do something means either to write the programs, to execute the programs in the Java, the fundamental required thing is JDK, Java Development Kit software. So once you have the JDK in your computer, you can easily play around with that. So part of the Java. So how this Java has been started, what Java provides, and how the Java has been available to you. So if you talk about some of the facts, so you can find some of the history, when it was started, how it was started, and you can just take a look after this. But you know, the very beginning, how the intention of inventing the Java software would be completely different, but later it was molded in such a way to use the Java programming on the client side applications as well as server side applications. And it went beyond, and Java has been using in many different ways. If you want to really understand some of the underlying facts, how Java being used, so you can get some of the facts about the Java software. So Java is everywhere. If you look at this, around 90% of enterprise desktops runs Java software, and around 89% of computers in the US, they run the Java. 9 million Java developers you can find worldwide, and it's like a number one choice for the developers as well as number one choice for the development platform. And around 3 billion mobile phones running the Java as a platform in it, and 5 billion Java cards in use, around 125 million TV devices running the Java software inside the TV to launch or to run some of the Java related applications or doing the interaction with the backend servers. You know, so nowadays a lot of smart TVs are coming, right? So they run the programs in the TV itself. So if you start talking about the facts, Java is being used everywhere. Okay, and you don't get surprised even if they started running the Java program in your car also, and that can start doing the interacting with the servers to exchanging the signals. You don't get surprised for that. Okay, so that's where how Java was started, and later how it being used is it grows like very exponentially, and you can find huge number of Java programmers across the world. So Java, basically, what is a Java? Let me ask you this question. What is Java? So people could tell, hey, it's one of the programming languages, but it's much beyond that. So Java is a programming language. I agree with you, I don't deny that. So it's a programming language. Using this you can write a programs, but much beyond that, it's also a platform. Java itself is a platform where lot of other apps, programs will run on top of the Java. Let's take Java in the Android phones. It's a platform where all the apps will execute, right? So Java is not just limited to the programming language, it's a platform. And Java, in the beginning, it started available in three different flavors. So one is micro edition, standard edition, enterprise edition. So they divided whole Java platform into three different parts. So one is called, so Gaurav is asking one question, what do you mean of platform? So platform is not just a programming language, because platform provides services to run some applications on top of it. Let's take Windows. Windows is a platform, right? So on top of the Windows, you can do many different things. You can do Microsoft Office, you can do the browsing, charting, emailing, you can run the servers. So means it's not just meant for the programming, it does provide the services. Using the services and other applications can run on top of it. Make sense, Gaurav? So this Java available in 3 different parts: micro edition, standard edition, enterprise edition. So each flavor is meant for something, it targeted for something. So if you take the macro edition, in the early days mobile phones are not as capable as today's mobile phones. Do you agree? Absolutely. Today's mobile phones are as good as the computers. If you check the Samsung Galaxy, so it's coming with 8 core, means inside the phone there are 8 CPUs running. You believe or not, there are phones with 64 core which is going to be coming to the market. So today's phones are completely different from the earlier phones. Earlier phones are very limited in terms of memory, very limited in terms of CPU. So for such kind of phones, if you want to write a program, it should be very optimal program in terms of consuming the memory and taking the CPU time. So that's where it will have its own challenges. They introduced Java as a macro edition, which is they did all required optimization to write a program which can run by consuming very limited resources in these kind of small devices like a cell phones, PDAs and all. That's where micro edition being used. And Java standard edition is a Java core fundamental functionalities has been provided part of this, as well as they also provided some kind of GUI APIs to build the application which only runs inside your computer. And whereas Java Enterprise Edition is meant for the server-side application development. And in our training, we are going to focus on the Java Standard Edition and Java Enterprise Edition. Means we are going to learn what is a Java and how do you write a Java programs. So what are the Java basics, then how we can use these Java features for writing a server-side applications in the Java Enterprise Edition. So we are going to learn these two. Okay, so but once you become familiar with the Java programming and fundamentals, I'm sure you are not just limited to this. If you have enthusiasm, if you have a interest to learn other things, you can absolutely learn. So now the Java gates are open widely now, so you can enter, you can learn more about the writing a Android applications. If you know the Java, it's not that tough for you. It's a learning one more API, right? And even based on the Java, a lot of new things are coming. Hadoop and big data. So completely the Hadoop framework has been molded on top of the Java APIs. So if you know the Java, you can easily write the MapReduce programs. You can execute your program to process around hundreds of petabytes. So that's what Google, Amazon, Facebook, LinkedIn, these guys are doing, because they are having a huge set of data and they don't know what is the efficient way to process. That's where they came up with, initially the Google started, but later that was picked by the Apache and made that as open source. That's okay. Let's come back to our basics. So if you know the Java, you can do many things. That's what I want to convey. So each platform is meant for a specific target devices. It's not for one edition, it's for all types of devices. And to understand Java platform, what exactly it is, so how I can use it and what it provides, and you can look at this diagram in a single glance what is a Java platform looks like. What will I get it? So basically JDK, this is nothing but a JDK, Java Development Kit. Just know what we saw, install the Java software. This is what exactly it was. So in our training, I'll slowly take you through various, all of these to understand what is the Java platform. But let me give you a quick overview. So first of all, you will be having a very much underlying a piece of program called JVM. I'm going to explain you what it is. Then you can find this line. This is called JRE, Java Runtime Environment. So JDK ships along with a certain features implemented. By using those, you can write the high level programs. I want to connect to the website from my Java program. I want to download the source of the web page. I can do that. Or I want to create a data structure which can process the data very efficiently. I can do that. I can delete a folders, I can create a folders, I can create a files, everything I can do that. So for all of this, the required underlying programming has been provided with the Java. So this is what is called JRE. I'm going to talk about little bit more. So once after this. And beside that, Java will give you some tooling. So how I'm going to compile my program, how I'm going to run my program, how I'm going to generate the documentation, how I'm going to create the libraries, and how I'm going to run my program in the headless mode, and many more things. You should be able to do it so by using these tools. So this is how your whole Java software looks like as a one view, but we are going to learn one after other slowly going forward classes. Okay, to understand some of its components, what exactly Java? So rather than talking about the components first, let me write a one simple program to understand these concepts. What's exactly happening when I write a program and compile and execute, what happens inside. Then let's write a one simple program called hello world. Usually I like to start any programming language with very quick to understand what is that and how can I execute it. Then we can deep dive into that programming world, programming language. So let me show you how I'm going to write a first my program in the Java. So whatever editor you might be having in your computer, you should be able to do. And moreover, you don't do it now. So after the class you can try this. So I opened one editor called edit++. So I just opened it and I'm going to write my first Java program. So to write a Java program you need to follow some of the syntaxes and guidelines. You have to follow them strictly to write a program. So why, we will understand one after other going forward. So you have to write a program with public class, and what is the name of the program. I want to write a program which can display hello world as a message. Then let me give hello world is my program name. That's called class name. And the syntax wise, I have to start the program, I have to end the program. And this is the public is a keyword, class is a keyword. So you have to start your program something like this: public, class, and name of the program. And once you write, so once you can think of, you have a big building, but no matter how big your building is, you need to have a main door to go into the building, right? Something similar to that. So to write a program to start execute, you need to have one entry point. Okay, so that entry point in the Java is nothing but a public static void main. This is my main method to enter into the program when I start executes. And the syntax wise, this is the syntax of writing the main method. You have to write public static void main and parenthesis open string and arguments as array. Why we are writing this? I'm going to explain you the meaning of each and every keyword going forward. But for now, remember this syntax. So every time when you write a class, this is the class. How do you write a syntax? And this is the opening braces is nothing but a starting of the class, ending of the class. Starting of a method, ending of a method. this is the syntax to write the main method in the Java. Okay, just remember the syntax for now. So to print a message on the console, you have to write system.out.println. This is how you have to write. So in case of C, C++, you can write at the printf or cout, right? So equivalent to that, in the Java, you have a system.out.println. So I'm going to write whatever message I want to print. I'm going to write inside the double quotes, which is going to print on the console. Hello world. So this is the message I want to print. That's why I wrote inside the double quotes. And in the program, every line, every statement ends with the semicolon. Wherever semicolon means, that's a one statement in the program. So this is what my program looks like after I completed this hello world. Then I have to save this program into a file. So let me click on the save. So I can save wherever I want, but I usually follow. I created a C work folder. Inside the work folder, I'm going to create my program as a hello world, or I can say Java first session. So some meaningful way to create it, and inside this Java first session, give the name of the program as a hello world. And these Java programs will have an extension called .java, and making sure they are getting saved with the .java, not the text extension. Okay, just click on the save. So this is nothing but writing a program. You have to follow the syntax: public class, name of the program, starting curly braces, ending curly braces. Then you have to write a main method as an entry. So into the program, I wrote a public static void main, and here I'm printing a message called system.out.println hello world. Means this is going to print on the command line. So go to your command line program and go to the place where you saved the program. C cd work Java first session, and if you want, you can look. Here is the place where I'm storing and making sure you are having a .java as an extension. All the Java programs will have a .java extension. And if you observed or not, there is we followed one guideline. Have you observed that? Do you see any kind of specific kind of practice? Did you see it here? If you look at my class name, hello world. What is my file name? Hello world. In the Java, there is a practice. It's not just a practice. Beyond that, the name of the class same as name of the file. So you might get a question: if I give a different, will not work? It will work, but we'll see that going forward. So just follow the practice. Give the same name to the class and name of the file. So after I do this, now to execute, first, this is a Java program. Who can understand? We can understand it. As a programmer, as a human being, we can read this program, we can understand it. But to system to understand, what I supposed to do is I have to compile the program javac hello world dot java. So what happens here? We are compiling the program, means translating the high level Java program into a system understandable format. So what it generates is the output of this compilation is a byte code. I'm going to talk about it, don't worry. So then try to run the Java program by writing a Java command hello world. I wrote a Java hello world, and I'm not doing any extension. And before going to run this, let me show you what is the output of the compilation. You can see this dot class. You can see that dot class. Let me change these sizes. So yeah, I'm sure you must be able to see it very clearly. And here you can see the dot class file got generated as an output of compilation. So this dot class file contains bytecode. Okay, so to run this bytecode, I'm going to write Java, then hello world. Java, then hello world. Just type enter and you can see the program executes and it gives you the output as a hello world. This is what just we did. Just you wrote a program and compiled it and executed, you got the hello world as an output. So what's happening here? So to understand that, let me take you a little bit further. So you wrote a program using some editor and saved that program and compiled it, and after you compile, it's a one-time job and it generated a bytecode that's called class file, and using the class file you compile the Java, you ran the Java program, you got the output. This is what we did. So basically what's happening here? What is this terminology? So how my program got executed? To understand that, understanding that concepts is so important because many people won't really realize what's happening in the execution time. So we installed a software called JDK, that's called Java Development Kit. This is called Java software, and we talked about a new terminology called JRE, that's called Java Runtime Environment. Right? So as well as there's other things called bytecode, JVM, garbage collection, GC. So JVM is nothing but a Java virtual machine, and bytecode is nothing, GC is nothing but a garbage collector. So these are some of the important fundamentals you need to understand to know what's happening in the Java execution cycle. So we already talked about it. Java Development Kit is a software where that will be preliminary requirement to write and execute your Java programs. So to understand, so I'm going to give a quick formula. JDK is equal to JRE plus JVM. So if you combine your JRE, JVM, or I can also tell you some tools, is nothing but a JDK software. So if you combine the JRE, JVM and tools, okay. So what is a JRE? Runtime environment. See, when I wrote a program, I use something called system, right? I use something called arrays. So part of the Java software, these things were already implemented, and they wrote a program to know when I write a system.out.println, they wrote a program already, so you print this on the console. That's what they already implemented, part of the Java software. So like this, they provided implementation for many things, like how to do the socket programming, how to open the files, how to read the files, then how to deal with the underlying operating system threads, right? All these things they created as a programs, as a Java programs, and they shipped along with the Java software, and we are using those very fundamental programs, and we are writing our own programs on top of it. And to compile and execute this program, you need to have those dependency programs. All of them they're calling as a runtime, because you need those programs to run your program. In the runtime of your program, absolutely you require the programs which are shipped along with the Java software is called JRE. So means if you want to run a program, you require JRE. So And along with this JRE, when you say JRE, you will also get runtime classes or runtime environment plus JVM. JVM is nothing but a Java virtual machine. Tools are nothing but the Java compiler is a one tool, Java.com generator is another tool, and many other tools will be shipped along with the JDK software. That's called is tools. But here the important thing to understand is JVM. JVM is nothing but a Java virtual machine. What it does? Here, so once you compile your program, what is the output of the program? Compilation. Once you compile your program, the output you got as a bytecode. So bytecode is a unreadable format which generates after your compilation. So who will understand the bytecode? Do you understand the bytecode if I open the file? Absolutely no. Does Windows understands? Absolutely no. Does Linux? No. Solaris? No. Then who will understand? Only JVM will understand this bytecode. Only JVM will understand this bytecode. So to execute the Java program, so here bytecode is platform independent format. Means whether you are running this bytecode on the Windows, Solaris, Mac, Linux, no much aware, but the bytecode is, it's a one type of bytecode. No one will understand, no operating system will understand. So the JVM understand the bytecode. So what JVM does is, when you are executing the program, he reads the bytecode, then generates instructions understand by underlying operating system. So what JVM read the bytecode, convert that bytecode into a machine understandable format, your OS understandable format, and those instructions given to the operating system, then operating system will execute and give you the program output. So that's what is JVM. Again, it's not the hardware, it's a piece of software program sitting inside the JRE. So let me ask you a question. To run the programs, what is the primary required thing? To run the program, based on this discussion, to run a Java program, what is the preliminary software I need to have? You are right. JRE is the one which is primarily required. So that comes with the runtime environment and JVM. You are good enough. You don't require the whole JDK to be present. So that's why if you look at wherever you have a JRE, in the mobile, in the TVs, in the computer, that's why when you're buying the new laptops, the JRE comes as inbuilt. You don't have to install the JREs. That comes very inbuilt. In the all Windows laptops you can find it. So what the JVM can able to read your bytecode and convert into a machine formats, machine instructions, and given to the operating system to execute. But the fun thing is what's happening in the JVM. You can look it here. So this is a Java program. After your compilation, it will give you the bytecode. And this is, if you look at the inside the JVM, what is the inside of the JVM? You can find a class loaders, you can find the interpreters, you can find a JIT compilers. So finally, this bytecode will be compiled into a code which OS understands, and that gets executed on top of the operating system and give you the output what you're looking. So these are the few components which sits inside the JVM. Other than this, there is another component called garbage collector. So basically what this class loader does is, class loader knows how to load the bytecode into the memory. But other than that, it is having one more beauty. So when class loader loading your bytecode, it also knows how to load all the dependent programs. For example, I wrote a program, my program depends on your program. Then when class loader loading my program, class loader understand looks like I'm depends on you, then let me load you also first. Then it will also load me. So that's what is the class loader does. And this interpreter JIT compiler sit inside your JVM to convert your bytecode into a machine instructions and giving to the underlying operating system. These two are converting your bytecode into machine instructions. You might get a question, hey, why are we having two? There is a difference how these two works. Interpreter converts line by line of your bytecode, whereas JIT compiler convert a bunch of code will be converted to the machine level instructions at one shot. So basically when this interpreter will be used different from when the JIT compiler. Usually when you're running the server applications, they will use the JIT compiler. Initially it takes more time to compile the bytecode into a machine format instructions, and it also generates some of the optimized output to execute the program very efficiently, because server requires efficient program to execute. So these are the techniques how they fine tune the JVM when they are executing the server mode and client mode. For now, we don't have to really bother about it. But these two are the one which will take the bytecode and convert into machine format instructions and execute on top of the operating system. So here one question Gaurav is asking, does interpreter convert bytecode into machine understandable instructions? Yes. And those instructions get executed on top of the operating system. The one more important thing is, when you're writing the Java program, you least bother about the memory. When you're writing a Java program, don't worry about the memory. If you are a C programmer, you must know when you're writing a C programs, and at the end you will write a destructors to clean up your memory. If you don't do that, memory leaks will happen. This is very often quite common in the C and C++ programming language. But in the Java, yes, in the Java also there could be memory leaks, but not as common as C, C++. So in the Java, you absolutely don't worry about the memory. So once you execute your program, and inside the JVM there is a piece of code called garbage collector. It knows what to clean up. Means what are the Java objects are not being used at this time, let me kick them off from the memory. It knows how. It uses certain algorithms like sweep and mark and many different algorithms, and it will start with one Java object and it will look, does it have any references with other Java objects. If yes, then you keep it, otherwise mark it as a cleanup candidate. So like that, it will go across all the objects which are sitting in memory. Then it will try to clean the memory as and when required to make the space available for the new programs to be executed. And this is completely sitting in the JVM, and who will control it? JVM. So we don't have to deal when my garbage collect will execute. When should I kick off the garbage collector? I completely don't care about that. Now let me ask you some of the hard facts. So we talked about Java is platform independent programming language, right? So means if you write a bytecode, if you have a Java code compiled into a bytecode, and the same bytecode you can execute on Windows, Linux, Mac, Solaris, no matter what operating, even in your mobile also. I mean, if your mobile having the similar kind of JVM, just why not? I can run the same program in my mobile. So that's where Java became platform independent programming. So write a program, execute wherever you want. But how it is possible? The magic of this platform independent is just because of bytecode and JVM. So if you talk about the JVM will take the bytecode, convert into machine understandable instructions. Let me ask you a question here. Does JVM a platform dependent or independent? Yes, anyone can tell me? JVM is a platform dependent or independent? It must be dependent, right? It must be dependent because JVM converts the bytecode into machine understandable. Means if you want machine understandable, then how that machine works you should know. Windows represent the machine instructions different from the Linux. So Mac, Solaris, right? So JVM take that bytecode. Okay, this is a Windows. Let me convert this into this form. The Windows will understand. If it is a Solaris, okay, let me convert this into other form what Solaris can understand. Then you must correlate why I have to choose platform when I am downloading the Java software, right? So because JDK comes along with the JRE, so the JRE contains the JVM which is platform dependent, so I need to download the appropriate JDK version which is compatible with your operating system. Then that comes with the JVM which can run on your computer. If you download the Linux one on the Windows, that doesn't work because Linux JVM don't know how to convert into a Windows ones. That's where, so JVM is the platform dependent, whereas Java is a platform independent. Don't get confused here. And let me ask you one more question. Does garbage collection is platform dependent or independent? Yes or no? So absolutely. So garbage collection also a platform dependent because it always deals with the memory. The memory representation is different from Windows to Linux, Linux to Solaris, Solaris to Mac. So they don't follow the same way to organize the memory for all these operating system. So if it is dealing with the memory means it must be platform dependent. So the JVM and internal programs could be a platform dependent, but on top of it whatever is there is a platform independent. The tooling could be platform dependent. Some of the tools. Sounds good. So am I clear to you? So what happens when I write a simple Java program and executes it? Yes? Any questions? So we saw one simple program writing and executing this program. How much time it took? I'm sure it took more than a couple of minutes to write this program and execute it all together. But this is so pain. I can't wait to just to write a one simple program, but in the real application we are going to write thousands and thousands of the programs. It's tough for me to write these things on the editor. So what is the best way to do? Let me quickly show you something, then we'll talk about detail going forward. So this is my Eclipse. I'll come here, I can create a Java project, very simple, Don't worry, I'm going to talk about the Eclipse very in detail when I'm going to talk about the Eclipse setup. I'm going to say Java project or say Java first session. Just say name and just click on the finish, and my Java project has been created here, and I'm going to write a simple Java program called class hello world. Okay, then I'm going to use public static void main. When I click it, surprisingly you can see the whole program got generated for you. The whole program got generated. Now if I want to write a system.out.println sys and just press Ctrl space, you will get everything, and just write hello world. The same thing, you are doing everything in the command line in just like that. And if you want to run the Java program, you don't require the compilation. This Eclipse takes care of automatically compiling your program. Just right click and say run Java application, and you must be able to see the output here. So you're doing everything in one place. This is the beauty of the tooling. I'm going to introduce you the Eclipse probably in the next session, and we will learn how to set up this, how to use this, and whole our following sessions I'm going to use the tools, not the just editor. Editor is not sufficient. I'm not going to work on the editor. I'm going to work on the Eclipse once I get into job, right? Or some equivalent kind of IDEs, right? And I'm going to use the two different tools, IDEs like Eclipse and STS. STS is also built and enhanced on top of the Eclipse. Don't worry, I'm going to show you. So this is the beauty of using the tooling, other than just write your programs and execute on top of the command line or editors. Okay. So let me give you one more simple concept called comments. So comments is one of the important portion in the program. What is that? What is that? So when you're writing the program could be the simple, the program could be the complex. So let me ask you one question. I'm sure you must have done that when you were like a childhood, like when you are learning for the mathematics, especially in the maths, when you're doing the complex calculation, you used to describe it, what it does. Or so you must be describe the geometry, how to write a kind of, I forgot the terminology, but like triangle, the circles, peripheral, and all these things you will describe what exactly you did, because that's a complex thing, tough to understand what it is, and you used to narrate that, and you used to tell what is the importance of that. Make sense? The same thing happens in the programming. Today I write the program, tomorrow you're going to work on my program. The software is so dynamic. The person who are going to work on the program will keep change, right? No company will expect only one person is going to work on my application forever. No company does that, and in fact that is not possible. So people will keep move the jobs, and especially when you're writing the complex programs, so other people tough to understand what is that. That's where we need to write a adequate comments in the program, so that will explain you what that piece of code does. So in the Java you can write three types of comments. So let me show you what are those. So one is the C++ style comments, C style comments, and special Java comments. I'll explain you what each of it. In the C++, you will write the slashes in front of a line, and this will considered as a comment, and it is a one-line comment. So using this style, you can comment one line at a time. You cannot comment more than that. You will use the forward two slashes, and that will be considered as a comment, and this line of program will not be executed when you are trying to run. Or sometimes this comment would be ignored by the compiler. It will completely remove this comment instruction during the compilation time. And another type of comment called C style comment, you will start with slash star and ends with star slash, and whatever in between is considered as a comment. Means that piece code in between these symbols will not be executed. And another type of comments called Java doc comments. You will start with slash 2 stars ends with star slash. This is called Java doc comments. So you might get a question, so why you are going to use all these three types of comments is differently you will use it. So basically when you are running the program, so you will be having the similar kind of line, one more saying the hi, but suddenly you don't want to print this hi output. You can simply comment by using the two slashes. You, instead of removing the whole line, you just comment it. Or you might be doing a calculation here, like into today, don't worry about the calculation and all, I'm doing some calculation, and so it might be having a importance of why I'm doing this calculation. If I don't explain what it is, nobody knows. Then you can write a comment saying that, hey, this is I'm doing for specific purpose. So why I'm doing this calculation, I'm telling, so at least the person who is going to look this program next, okay, by reading this comment, he will understand why I'm doing these calculations. So this is the C++ style comment, this is C style comments. And when you're writing a code, you can give the adequate information in the program to understand what it is doing. And you can use any of these comments when you're writing the program. So then you must be getting a question, hey Kishan, where I'm going to use the Java doc comments? That's a beauty question, because that is very, very useful. Let me show you something over here. So usually Java doc comments will be used in front of a class and in front of a methods, in front of a variables. You can tell, today I started learning writing the Java programs, and this is my first Java program. And here also I can write a comment in front of a methods. This is the main method to execute this program, and what exactly it is doing? It is printing hello world message. This is what I'm going to describing about my method and class by using the Java doc comments. What is the beauty of it? So means I'm documenting my program in the program itself. So means documentation and code settings together. Then you will say, hey Kishan, instead of document here, better you document in separate documents like a Word document or some text pad, so people can easily read it. Yes, you are absolutely right. So some people cannot open the Java code and read it, right? But don't worry. So Java provided a solution called Java doc. So if you look at the Java doc, this is the tool provided along with the JDK software. Using the java.doc comment, java.doc tool, you can generate very nice, beautiful HTML documentation out of this the Java classes what you wrote. So let me quickly generate it and show you. So I can say java-doc -d. I'm going to create a folder called doc, and inside the doc I want to generate the documentation. And for my Java program, I'm going to generate the Java documentation. Okay, it's doing some. I'm going to remove this line for now. So that's showing the some error with the program. For now you can ignore it because I'm not putting the semicolon. That's why it is started complaining the issue. But you know, the beauty is, go to the place where you have the Java first session and you can see this doc. There's a beautiful documentation generated on top of the Java program. And just open. So let me open this with, see, whatever I wrote in my Java program, it got showing here. Today I started learning writing Java program. This is my first program, and this is the main method to execute this execute this program, and it is printing, it's a spell mistake, hello world message. So by writing a sufficient java.doc comments in the program, and at the end you can generate the documentation using this tool, and it is going to be a beautiful documentation for all of the programs you wrote. And this is how the Java documentation been distributed. Java, they did not provide you separate Word document. If you look for Java or Java API, I'm sorry, I wrote mistakenly, but okay, anyway, it's corrected me here. So Java API you can find. So all the Java runtime provides you the set of classes. Those class information has been provided in the Java API. This is a beautiful. So better to, you know, you can keep bookmark this always. This is going to be useful. Let me say Java API, and I'm going to keep it on my toolbar. So then I'll never miss it in the class. If I want to open, I'll just open it and I'm going to show. And you know, reading the Java API is so important because this contains very detailed description what each and every class does. So if you take this system, it tells you this system class contains several useful class fields and methods. It cannot be instantiated. We will understand this technical terminology, but this is so important. As a Java programmer, you might need to refer this every day-to-day life. So let me put this link in the text pad and you should be able to access it, or just look for the Java API, you will find it. API is nothing but application programming interface. I'm going to explain you that keyword going forward, don't worry. Okay, so from this, writing a simple Java program and by giving the java.doc comments, and you can generate a beautiful documentation. And I would like to tell you some of the guidelines from, you know, so when you're writing a program, so the first guideline what we learn is, you know, give the same name to class and file, and give the .java as an extension to the file, and give some meaningful names to class, and write required java.doc in the program as and when and wherever you have required. So Raja was asking, can we generate some same documentation through the tool Eclipse? Raja, don't worry. So how I generated the documentation today, I wrote it as a command line, but you know, you don't even require to run that command. So we are going to learn some of the sophisticated tools that will generate you whole website that includes along with this API documentation. Okay, I'm sure Eclipse also does that. And but beyond that, we are going to use in the production, in the real application, the number of classes are more and complexity is more. Sometimes the programs might be sitting in different places, like in the SCM control SCM systems. So you have to download the program and run this. To automate that, we are going to use the build tools that does this all this job. Okay, so I'm going to show you different ways how we can generate this documentation. Don't worry for now. So, and you as a, so by following the good practices, I'm always believe like I can distinguish myself from other programmers, so who follow these things. So you believe or not, in the company this is one of the standard to write a nice and beautiful documentation for your program. If you don't do it, you looks like novice for me, because you're not like an efficient programmer, you're not like a good programmer. So you can write a documentation as and when you want, and you can write a nice program of it. And as I told you, in the Java, this is nothing but a one statement. Every statement ends with a semicolon. So how I'm going to write a block? Block is nothing but a set of or one or more statements is called as a block, and it starts with curly braces open, curly braces close. This is nothing but a one block. So anything, any number of statements inside the curly braces open, curly braces close is considered as a one block. The system, the public static void main is opening a curly braces open, curly braces close. I can say this is a block of statements. Okay, and when you're writing a system.out.println, so let me write it on the notepad, text pad. Here I wrote a println, right? And I'm going to show you something called system.out.print. I'm writing today, let's assume. Okay, I'm just saving the program, and every time, remember, when you make a small change to your program, you have to compile it and you have to run it, because the newly added program not been generated the bytecode, right? So that's why you have to recompile, then run. You can see it. So you are saying a hello world today got printed. You don't see a big difference between the print and println, right? But let me print today one more time and compile it. Sorry. And I'm rerun this program, and you can see today and today came in the same line. How come hello world came different line and first today came different line? So the second today came in the same line. So when you say print ln, ln means it's a new line. So means after printing the hello world, it will append the new line. After printing the today, it doesn't append the new line because you did not included the ln. So that's why these two todays came in the same line. Okay, so let me give you a quick overview what we did in today's class. We started with Java, and we talked about the Java Insight, like JDK as a platform. Then we talked about the JDK, JVM, and in the JVM, inside of the JVM, like a class loaders and interpreters, garbage collectors. Then we talked about how to write a simple hello world program and how we can execute on the console command line on the same program, how quickly we can write in the Eclipse. Then we talked about the comments. Then we talked about the simple statement for block statements. Then we talked about writing a system.out.println versus print. These are the few things we talked in today's class to get the very a basic overview about the Java, right? And you can, so these like a very few fundamentals how we can start with it, and we can get more and more insight into the Java program in the following classes.